Hi there, everyone. This video is for anybody who did not attend the Google Meet on Tuesday, or if you attended and maybe just need a little bit of a refresher. So, everyone should have attended class on Tuesday from home since everyone was e learning. And what we did is we just talked about and discussed activity 14 here. So last week, what we discussed was the braking distance and how speed affected our braking distance and how mass affected our braking distance. We know that if we increase the speed or if we increase the mass of a vehicle, that it creates a longer braking distance, that it's harder to stop the car. This week, what we're going to do is we're going to talk about um, some other factors that also affect the braking distance and actually coming to a stop. So, the first thing that you will need to do is that you will need to read this intro right here. And after you read the intro, or as you're reading the intro, make sure you write down 2 or 3 key ideas here in um, the note section. And you will also need to make sure that you um, write a working definition for your keywords. After you complete that, then you're ready for the procedure. And click on that second tab. And what you'll find here is it tells us exactly the procedure that you're going to do step by step. First thing I'd like to point out is that you are looking at 4 different scenarios here. You are looking at an alert driver who's driving on a dry road, an alert driver who's driving on a slippery road, a distracted driver on a dry road, and a distracted driver on a slippery road. So what it says is using the following data and the equation below, calculate the distance a vehicle travels during a driver's reaction time. And so the distance a driver travels during their reaction time, we call that reaction distance. In order to calculate the reaction distance, you're going to take the initial speed and you're going to multiply that by the reaction time. So in this first scenario, we can see here's the initial speed or the driving speed, and we're going to multiply that times the reaction time, which is right here. So we see that it is 4.5 times 1.5, and I'll just come back over here, pop up my calculator, 4.5 times 1.5, and that's equal to 6.75 meters, right? So most times I would have you keep it at, I'll tell you to round a number to the nearest tenth. This time I'm actually going to tell you to round it to the nearest whole number. So 6.75, we would round that, and that would round to 7 meters. So that's the reaction distance. After you calculate the reaction distance, then you are ready to figure out the stopping distance. So you have to use this equation here, a number 2, to get the stopping distance. This is going to be the reaction distance plus the braking distance. So I'm going to take this number plus this number, and that the sum of those two will be my stopping distance. So 7 plus 1. Hopefully you don't need a calculator for that one, but that is 8 meters. So the stopping distance is 8 meters. So let me kind of give you a scenario here. If I am driving along and paying attention on a dry road, and I'm driving at 4.5 meters per second, which is only 10 miles per hour. So I'm not driving very fast. So maybe I'm in a neighborhood, and all of a sudden a deer drops out in front of me. It will take me as it will take me, as soon as that deer jumps out in front of me, about 1.5 seconds to react to that deer jumping out. And that means in that time, I will travel 7 meters during that time for me to react. So even with me slamming on my brakes after that 1.5, then the car will still will go a little bit because there's the braking distance, which is 1 meter. So this is why I have to add the reaction distance plus the braking distance to get my complete total stopping distance, which is 8. You are going to solve all of the reaction distances for all 4 of these data tables, as well as the stopping distance for all 4 of these data tables. Let's do one more together. Let's go down here. That was an alert driver on a dry road traveling at a slow speed. Let's go down here and see what would the stopping distance end up being for a distracted driver. So maybe somebody who is on their phone or drinking coffee, or if they have are messing with the radio, or they have a screaming kid in the back. So some sort of distraction on a slippery road. So it's either has ice on it, and let's have them travel at a fast pace. So at 80 miles per hour. So maybe they're in a rush and they're on the bypass, and so they're speeding on the bypass. Okay. So to calculate you first have to calculate the reaction time, and you're going to do that by multiplying the speed times the reaction time. So that is going to be 36 meters per second, which is equivalent to 80 miles per hour, times 3 seconds as a reaction time because the driver is distracted. That is going to be a total of 108 meters. So by the time the distracted driver sees a deer pop out, it will take them 3 seconds. And in that 3 seconds time, they're going to travel 108 meters before they hit the brakes. Now, because the road is slippery, there's less friction, the braking distance is also going to be longer. So this says it's 218 meters for the braking distance. So to get the total stopping distance, I have to add the reaction distance plus the braking distance to get my stopping distance. So 108 plus 218, that is 326. So right here, I'm going to type 326. So again, make sure that you complete all 4 of these data tables. After you complete all 4 of the data tables, then you need to look for any patterns that you notice in your calculations for the reaction distance and the stopping distance. And go ahead and you should list 2 or 3 patterns that you see. Okay. The final thing that you need to do is you need to set up the graph paper here for number 4. I'm not super concerned if you get all 4 lines graphed, but I want your graph paper to be set up. So when we set up the graph paper, remember about tails. I use that acronym for graphing. And the first thing is the T, which is the type of graph, and the title. Well, the type of graph that we're going to make, since we are comparing, hold on, let me go back here real quick. It says you're going to make a graph for the stopping distance versus the driving speed. So you are going to show the relationship between how the driving speed affects the stopping distance. So anytime you're showing a relationship, that is going to be a line graph. So we know we're going to make a line graph. And if you would read down here a little bit more, you can see it tells you that you're going to plot points and draw a line. And so obviously it's a line graph. But again, we're showing line graphs always show the relationship between two variables. And we're going to see how the driving speed affects our stopping distance. So make sure you add a title that is descriptive of what this graph is going to show. The next thing that you need to do is come up with the axis, which is on what axis. And if we look back here, it actually tells us that the stopping distance is going to be on the y-axis and the driving speed is on the x-axis. Think about which is the x and which is the y. Remember, x means no. If I shake my head no, my head goes back and forth. The x-axis is this way, it's a horizontal, and y means yes. If I shake my head yes, goes up and down, and that means the stopping distance is going to be on the vertical axis. So you will need to, here's our stopping distance, and here is our driving speed or initial speed. Okay. So that is the axes, and I kind of showed you the labels, but you need to complete the labels on yours. And then the final part is figuring out the intervals on the axis and the scale. So along the x-axis here, I have a total of 11 lines. And that is on the x-axis is the speed, the driving speed, or as listed here as it's the initial speed. So if I'm looking at each of these, you should notice that the speed is the same in all four data tables. And I want to make sure that I have the proper scale and I get all the way to the end of my graphing paper. So I need to look at what is the greatest speed, and the greatest speed is 36 meters per second or 80 miles per hour, but we're going to use the metric system, so 36 meters per second. To determine the scale, I'm going to take that 36 and I'm going to go ahead and divide it by 11 because I have 11 total lines along the bottom, and that gives me 3.27. Now, it'd be really hard to go up by 3.27 on each line. So instead, you're going to take this number and round it up to the nearest whole number. Don't follow the traditional rules of rounding of 5 or more, raise the score, 4 or less, let it rest. No, instead, you are going to just go ahead and raise it to the next whole number, which is 4. So that means we're going to go up by 4s. And I didn't fill them all in here for you, so you have to kind of think. But this one is 4, this one's 8. So what's this next line going to be? What's this one going to be? Okay, so fill those in. And then we have to come up with our intervals and scale on the stopping distance. So you will have to look at your data through all 4 of these and find the largest number. And there's a reason why I did this last one with you, because hint, hint, wink, wink, nudge, nudge, 360 or 26 meters is the largest stopping distance. So we need to make sure that our y-axis goes all the way up to 326, but still in equal increments. Now, if you count those lines up, there are a total of 14 lines. So I'm going to do the same thing here. I'm going to take 326. I'm going to divide that by 14 because there's 14 lines. and that gives me 23.28. Now, if I round that up to the nearest whole number, that is 24. But 24 is not a really convenient number to go up in increments. So instead, I'm going to suggest that you go up by 25s. So on the left-hand side, this will be 25. Well, then what's that next number? Well, then there's 75. Then what's these numbers? So make sure you fill these in, and your top number should end up to be 350. Double check your math and make sure that's correct. But you should have that all set up then. Okay. The final thing is that you then are ready to plot your points. You are going to end up having 4 different lines on this single graph. You're going to plot the points for the alert driver on a dry road in green, and that data will be in this first data table here. You're going to plot the points and draw the line for the alert driver on a slippery road in blue. That information's here. The distracted driver on the dry road, that would be in orange. That information's here. Then the distracted driver on a slippery road, you're going to plot in red, and that will be here. Let me just quickly show you how to plot the points, and you can give that a try if you'd like. Like I said, that's not required for tomorrow, but having the graph all set up is required. But if you'd like to give it a try, I don't want to stop you. So what you're going to graph, again, we're going to graph the initial speed or the driving speed, and the point is, and with the stopping distance. So here I have 36 meters per second is my X, and my Y is 326. So we have to find that point. So if I look back here, remember I'm going up by 4. So this is 32. That is 36, right? So 36 is right here. And it went up to 326. So I keep on moving up, moving up. Well, if this is 300, this is 325, and that's 350. So 326 is right above that. And I would make my dot right about there, right? So that would be one of my points for the distracted driver on the slippery road. You will have a total of 5 points for each data table. Again, you're graphing the initial speed and the stopping distance. So that should get you set up. If you have any questions, you can feel free to email me, and we will check over your graphs together in class and work on analysis questions together. Have a great day.